We are now more than 2 months since Russia invaded Ukraine. Many countries have imposed sanctions to put pressure on the government of Vladimir Putin, but so far sanctions have not included the sale of oil and gas. In particular, European countries are hinting that they want to put an embargo on Russian energy, but so far oil and gas continue flowing, for the simple reason that Europe has a big dependence of these resources from Russia. According to The Economist, Europe is paying 400 million euros every single day to the Kremlin to buy its gas, which indirectly continues fueling Mr Putin's invasion. Now Russia is putting pressure on Europe too. On 27th April, Gazprom, the Russian gas giant, stopped selling gas to 2 countries in the European Union, Poland and Bulgaria. We're asking questions about the war in Ukraine. We have economic, social and political considerations about the future of energy security. It's all up in the air. A couple of weeks ago, I published a video discussing the question of whether Europe can live without Russian oil. Spoiler alert, it can't, at least not now. There's a link to that video in the description below. Now join me in this video, where we will ask a similar question: can Europe live without Russian gas? The answer is complex and will be divided into 2 parts. This first video is part 1, the European dependence. Part 2 will look at the Russian angle. Before we look at the numbers, let me clarify a few definitions. First, when I talk about natural gas, I am primarily talking about methane or methane, which is a 1-carbon molecule that we normally burn as a fuel. Natural gas contains other components like ethane, propane, carbon dioxide, and water vapor, but they're very small and I will ignore them for the time being. Second, most of the data I will quote comes from the BP Statistical Review of World Energy. The latest edition has data from 2020. Third, the units I will use when quoting reserves, production, and trade of gas will be in billion cubic meters. And when I say 1 billion, it is equivalent to 1,000 million. Okay, let's start with reserves. 20% of the world's gas reserves are located in Russia. That's 1 in every 5 cubic meters. The next largest reserves are located in Iran and Qatar, who have 17% and 13% of reserves respectively. If you add them together, you will find that half of the world's reserves are located in just those 3 countries. As a side note, I know there are different types of reserves, including probable and possible reserves. But in this analysis, I am sticking to the numbers published by BP, and they refer to reserves that are reasonably recoverable from existing reservoirs under existing economic and technological conditions. It is also interesting to see how some countries have a lot of oil reserves, like Saudi Arabia, while other countries have a lot of gas reserves, like Qatar, and other countries have a lot of both, like Russia. Now let's look at gas production. You can have a lot of reserves and produce little, or small reserves and produce a lot. That's exactly what happens in this case. Russia has the largest reserves, but it is not the largest producer. That is the United States, which has less than 1/3 of Russia's reserves. Russia is the second largest producer, followed by Iran, China, Qatar, and others. The next question is demand. What do we use natural gas for? The largest use is in power generation, electricity. This is important, as you will see later. We also use gas to heat our homes and buildings. We fire industrial processes like making steel, and we also use gas as a raw material to produce fertilizers, hydrogen, and other chemicals. Today, gas contributes to 25% of the world's energy mix. We like gas because it burns cleaner than oil and coal. The combustion of methane still produces greenhouse gases, of course, but burning coal produces about 4 times more polluting substances overall. Also, power plants that use gas are very efficient and flexible. The big problem with gas is, how do we move it? After all, coal is a solid and crude oil is a liquid. And while today we have sophisticated supply chains, large ships and terminals to move them around the world, in the worst case, you could always move a solid or a liquid in a more rudimentary form. But methane is a gas. Moving gases can be difficult. If one country wants to sell to another, it has 2 options only: building a pipeline or moving gas as a liquid. Building a pipeline is expensive. It takes time and requires large political and geographic maneuvering. Some pipelines are thousands of kilometers long. They may pass through multiple countries or go underwater. Once the pipeline is built, however, moving the gas becomes relatively straightforward as we push it through the tube. But the location of the pipeline will be fixed. The second way to move gas is by liquefying it and moving it by ship. We call this LNG, liquefied natural gas. LNG gives us more flexibility because we can send the gas to different locations and we won't be constrained by the fixed position of a pipeline. But we require special technology. we need liquefaction facilities where we will compress the volume of the gas about 600 times and take the temperature down to minus 160 Celsius. I mean, for reference, the coldest temperatures ever recorded on Earth have been about minus 90 Celsius in Antarctica. Well, liquid methane is about twice as cold. We put this liquid methane in a special ship and we carry it as a liquid to the receiving port, where we again need special facilities to store it and regasify it in order to feed it into the grid of the importing country. This technology is very impressive. Thanks to LNG, we can move gas from the Middle East to Japan without the need to build pipelines. LNG is more flexible, but not everybody can do it because building and operating these terminals and ships is expensive. All in all, of all the gas traded globally, about 60% is by pipeline and 40% is LNG. But the proportion of LNG has been growing fast. Just in the last 10 years, LNG global trade went from about 300 billion to 500 billion cubic meters. Countries like Australia, Qatar, and the United States continue building capacity to export LNG. Now let's focus specifically on Europe. Where does Europe get its gas from? Well, the geography of Europe and the proximity to Russia means that pipelines would make a lot of sense. And indeed, 2/3 of the gas into Europe is imported through pipelines, of which about 80% bring Russian gas. Looking at a map of pipelines shows that some of the countries are more connected to Russian gas than others. The largest importers in Europe are Germany and Italy, who also happen to buy the largest amounts of Russian gas. More than half of imports in the case of Germany and about 1/3 in the case of Italy. Europe has other pipeline connections too, to places like Azerbaijan and Algeria. And Europe also receives LNG, mostly from Qatar and the United States, but also from Nigeria, Algeria, and even a little bit from Russia. Don't forget, Europe also produces gas. Norway is a large producer and exporter, and there's a lot of trade internally between European countries. The summary numbers look like this. Europe consumes 541 billion cubic meters. It produces 215, which means there's a balance of 326 that has to be imported. Russia provides 185 billion cubic meters, which is 57% of the total imports. And it's mostly by pipeline. If Europe wanted to stop buying Russian gas, it would have a problem. It would have to find 185 billion cubic meters of alternative supply, which is a lot. There is no other country that can supply that amount of gas. For comparison, the second largest importer into Europe is Qatar, with 30 billion cubic meters. It's about 6 times smaller than Russia. The pipelines connecting Europe and Russia have been built over decades. And of course, it gets cold in Europe in the winter, which means large amounts of gas are needed to heat homes, buildings, and industry. So now we know how dependent Europe is on Russian gas. But this is only half of the story. We still need to see how dependent Russia is on European demand, and also understand the political and economic consequences of Mr. Putin's action in the decision to cut the flow of gas to Poland and Bulgaria. But we will talk about this in part 2 of this story, Europe, Russia, and gas. I hope you enjoyed this video. There will be a link to other videos in the description, including my video on Russian oil. Feel free to leave comments, click like, subscribe, whatever you want. And I'll see you next time.